Good evening, sir.
Good evening, ma'am.
Ma'am, I am Dr. S. Prela Shairi. Could you please make me co-host?
You have already been made as co-host, ma'am.
Okay, ma'am. Okay, I'll check.
We'll begin shortly now, ma'am.
Yes, ma'am.
Good evening, participants. Before we begin today's session, let us hear from one of our proud alumni who will share his experience and thoughts through this short testimonial video. This is about our 2014 passed out Mr. Satyan Gnanasekaran, an Arjuna awardee and a Commonwealth Games winner. Playing the video now.
St. Joseph's College of Engineering. You choose, we do it.
Hello everyone, Satyan Gnanasekaran here, Arjuna awardee, international table tennis player and a proud alumni of St. Joseph's College of Engineering. I did my bachelor's in information technology and graduated in the year 2014. Everyone would always ask me, how did you manage studies and sport at the highest level? That's because of the tremendous support from the college management and especially the faculty of IT department. They were always there for me and supported me during my tough times. Those 4 years in St. Joseph's College was the turning point of my career, as the college management not only helped me to grow as an engineer but also as an international athlete. I then went on to become the first Indian ever to reach the world top 25 rankings. In fact, the college was the first to congratulate me and organize a massive felicitation function after I won the gold medal at the Commonwealth Games 2018. It was indeed a nostalgic moment for me. I would always remain a proud Josephite by heart. Thank you so much.
Good evening, everyone. Now I welcome all the participants to the third day of our online ATAL FDP on recent trends and future directions in AI for medical imaging. It is a great privilege for me to welcome Dr. S. Prela Shairi, a professor in the School of Computing, Department of CAC, Satyabama Institute of Science and Technology, Chennai, Tamil Nadu. She has completed PhD in the year 2014 in the field of computer science and engineering. Dr. S. Prela Shairi has published over 70 papers in reputed journals and chapters in books and participated in a range of forums. She has 21 years of teaching experience. She also presented various academic as well as research based papers at several national and international conferences. Her areas of interest includes overlay network, network and cybersecurity, transfer learning, and she has received many granted patents and funded projects also. We welcome you, ma'am. Ma'am, kindly take over the session now.
Thank you so much, ma'am, for this opportunity. I'll share the screen now. I hope my screen is visible, madam.
Yes, ma'am.
Thank you so much, ma'am. Thank you. I think, shall I start?
Yes, ma'am.
Yes, ma'am. Good evening to all. Today we are going to see a small topic on the federated learning and privacy preserving AI in medical imaging. First of all, I just want to thank the entire St. Joseph College and the Department of IT faculties, most especially my dear friend, head of the department, Dr. Heltin Janita. Thank you for giving me this opportunity, madam. And now we shall move on to our concept, federated learning and privacy preserving AI in medical imaging. Moving on to the motivation. First of all, we shall split this topic in three. I mean, why and what is the motivation of medical imaging? What is privacy preserving? And what is federated learning? And then we can have all these integrated as federated learning and privacy preserving AI in medical imaging. And if time permits, we shall see a small code, Python code, if time permits. As well, we will see some future directions of federated learning right now in the market. So we shall see what is the importance or the motivation of the medical imaging. So why we need to secure the medical image? That is very, very important. What is the reason behind to secure a medical image? Only if we need to know what is the reason behind to secure the medical image, then it is better to learn what is the concept behind it and what are all the problems we will face if we are not securing the medical image. Medical imaging actually plays a vital role in disease diagnosis, treatment planning, and patient monitoring. With the rise of AI and cloud-based healthcare systems, vast amount of sensitive medical images, maybe we can take either it as an X-ray, or it can be an CT scan, or it can be an MRI. Both are generated, it is stored and shared across hospitals and research institutions. However, these images often contain personally identifiable health information. That is very, very important when we are talking about a medical image. It should always have some personally identifiable health information that must remain confidential. That is always a confidential thing, because if it may be a political person, or it may be the image may be a person who is a celebrity. So if somebody knows it, and if we really want to tarnish the reputation of the such people, I mean, the hackers can also hack the images and do some unwanted things. So unauthorized access, data breaches, or misuse of the medical images can lead to serious privacy violations, identity theft, as I said earlier, loss of patient trust. In addition, regulatory frameworks, like we know that HIPAA, that is Health Insurance Portability and Accountability Act, we have, and GDPR require some strict protection of patient data. So whatever maybe, as we all know that now everything is distributed environment, we can get everything as the emergence of cloud computing is there. We can get whatever we need from the repositories. So the privacy preserving is very, very important. So that's what it is given here. Protect the patient privacy and maintain ethical standards and prevent the data breaches. That is very important, the data breaches and unauthorized data manipulation. Also, it should have in compliance with healthcare data protection laws, as I said, HIPAA, GDPR, and preserve the trust between patients, doctors, and institutions. The trust is very, very important between a patient as well as a caretaker. And finally, when we move on to an AI, it will support the AI development by enabling the privacy preserving data sharing. Maybe it is an example of federated learning also. So this is the main motivation why we need to secure a medical image. That is the main thing. Coming back to the next one, as I said, we are splitting the title into three. We just want to know what is the need for medical image security, what is privacy preserving, maybe we'll learn some techniques, and then what is the federated learning. Coming to what is privacy preserving, it is a protective, sensitive, or personal information. Privacy preserve means we are protecting some sensitive information that is, from being exposed, shared, or is misused, especially when data used for analysis, research, or AI training. So we all know that now it is the world of AI. AI is dominant everywhere. We can see good and bad in this actually. So when a data has been given exposed for analysis or research or anything, definitely the data has to be preserved. That is very important. And privacy preserving techniques allow useful data processing without revealing the actual private data. There comes our federated learning also, we'll see in the later cases. So when organizations or researchers use data such as medical images, financial records, or personal details, it is important to ensure that individuals cannot be identified. That is the person who is the particular person should not be identified, and their information remains confidential. That is important. Privacy preserving methods make this possible by allowing computations or learning to happen securely even across distributed systems. That is the privacy preserving. Now we'll see some common techniques what are there in the current scenario for privacy preserving. So these are some of the common privacy preserving techniques. One is data anonymization, that we all know, just removing or masking personal identifiers. Say for example, if we are now, even if we need some other data, so to some person if you are sending, we can even really mask such important things and we can send it. That is data anonymization. Even people, normal layman people will be doing it. Differential privacy, so adding some random noise to the data or results, whatever may be the results. If it is an image, we can add some random noise so that the original picture or the data cannot be detected or cannot be found out. And the final third one is the homomorphic encryption. Homomorphic encryption means encrypting. We all know that what is encryption. After encryption, we will get a data that, the text is called as a ciphertext. So in that ciphertext, doing some mathematical calculation is nothing but the homomorphic encryption. So I repeat, after encryption, we will get a ciphertext. So making some or doing some mathematical calculation in the ciphertext is the homomorphic encryption without ever decrypting it. So that is homomorphic encryption, one of the privacy preserving technique. So when we move on to this homomorphic, it will give, we can say it is a double encryption. It will be more secure. Okay, and next is secure multi-party computation. So this is also multiple parties jointly compute a result without revealing their individual data to each other. So you can find a difference, similarity between this secure multi-party computation, SMPC, as well as the federated learning. Okay, the same concept only, because this multiple parties, they will generate a result, but they will never reveal their individual data to each other. That is the SMPC. And federated learning means actually the data will be stored locally to the stations. Maybe it can be a hospital, as we are seeing about the medical imaging. Let's see about it as hospitals or the systems. Okay, we can say the local systems. And only the updates will be, model updates will be shared, not the raw data. But you may ask me a question, you have a similarity. What is the actual difference between this SMPC as well as the federated learning? SMPC is purely, cryptographic method. SMPC is a cryptographic method. As we know what is encryption, decryption, it is a cryptographic method. We will be doing some mathematical calculations one day. Whereas the federated learning is a machine learning approach. So this is the only difference between the secure multi-party computation as well as the federated learning. So now we can take as an example in the healthcare. Hospitals can collaborate to train an AI model to detect diseases from X-rays. Instead of sharing patient images, each hospital trains locally and shares only model updates. This ensures the patient data privacy while enabling the collective model improvement. Okay, so this is the thing which we are going to relate now. Now coming to what is federated learning. This is the next thing. The third one or the base, we can say, what is federated learning. So this federated learning is actually the core word of this federated learning is train together without sharing data. How it is possible? Training together, if something wants to be together, then something has to be shared. Is it? Because without knowing or sharing or revealing anything, how a model could be generated? It is possible in the federated learning. We are not going to transfer, or we are not going to show the raw data. Instead, we are going to share only the weights generated in the respective stations. So we will see more deep in the forthcoming slides. It is a machine learning approach that allows multiple devices or organizations to train a shared AI model without exchanging their actual data. That is federated learning. So far we have learned about what is the need for the medical image security, what is privacy preserving, what are some of the common techniques of privacy preserving, and what is federated learning also. Now, what is the advantages of federated learning? As I said, the data privacy and security, that is important, like patient records as well as the personal information never leaves the local device or the hospital devices. Okay, and it has some compliance with the regulations. Collaborative model training, multiple organizations work together to build better and more accurate model. When we are moving to a model, the ultimate objective is the model should have a accuracy. So that we will get with the help of this federated learning. Amidst we are using diverse data sets. Okay. Now, reduced data transfer. We are not going to transfer the entire data. We are not going to, since we are not going to transfer the exact as well as the entire data, our bandwidth as well as the storage requirements are very less when compared to the other networks. And model generalization is very important. That is also, it will make more robust and accurate across different environments. And finally, on-device learning enables AI to learn directly on user devices. If I have a smartphone, if I have to customize something, and if I want to have a model, then I can get it. User-friendly, it will be user-friendly only. Now, we'll see some difference between the traditional AI versus federated learning. So traditional AI means if I want to generate a AI model, the data will be collected and it will be stored centrally where we need to do some calculations. But in the case of the federated learning, the data will be residing in my own system. If I am indulged in that work, the data will remains, or the raw data will remains in my system only. Only the weights as well as the model which I am generating will be moved to the central place. And the privacy risk is high in the traditional AI because we are going to share the entire data. So the data can be hacked, the data can be breached. But in the case of the federated learning, the privacy is preserved because I'm not going to share the raw data. Only the model which I have generated is being shared. Now here in traditional AI, we have only single data owner. So the model which I have generated may or may not be good and may or may not give some exact or accurate values. So here in the case of the federated learning, multiple data owners are there. So they will be creating their own model. So finally, we are going to take an average weight also. So definitely the global as well as the generalization will be there. So we'll get nice, model. Easier management is in the traditional AI because I am the only owner who is going to create it. So the management will be very easy. In the case of the federated learning, it will be more secure collaboration. 1 minute. Okay, it will be more secure. Now, this is the picture for the federated learning in medical image. Okay, we'll see the picture. So, this is hospital A, and this is hospital B, hospital C, hospital D. And now I will say with this diagram, and then we will see some of the steps as well. We will try to explain you with a small code also. Okay. So you can see this is, suppose this hospital A, these people, I mean, these 4 hospitals want to generate a model to diagnose a brain tumor. Okay. They just want to diagnose a brain tumor. But this person may be having an MRI image. This hospital may having a PET image. This can be a CT, and this can be a multimodal images. Their images size or image types are not common. They are of different types. So this hospital A is having a brain tumor image where this is being logged because the raw data is not being transferred. But this hospital A is going to create a model, and then they are going to generate the model and transfer it to the global repository. Subsequently, this hospital B will also take this image, and they will never disclose the identity of this image. So they will be creating a model, and this model will be shared to the global model. So likewise for hospital C and hospital D. So what is be going here? Only the models generated will be moved to the global model. Now, there might be a question that hospital A has generated a model with its own file format, and subsequently all these hospitals might have generated a model with their own images which they are having. But how can a centralized system or a global model can be generated, saying that or justifying that all these models are correct? How it is possible? It is possible because the global model is now generated with the help of the federated average of all these weights. Okay, we all know that when we want to train a model, we need to initialize a weight, and then we will get some activation functions, weights, everything we will be getting. So that will be sent to the global model, and the global model, it is actually generalized by taking the federated averages. Now this is the step-by-step procedures. Initialization. So these are some of the steps. First one is the initialization. So what is initialization? It is a central server. It initializes a global AI model and sends it to all participating hospitals. So now we are going to generate what is okay. So now, okay, fine. So this central server will be sending it to all participant hospitals, and then the local training will be there. So what they will be doing, each hospital, as I told, each hospital will be training the model on its local patient images. The data never leaves the hospital. So here the data will never leave the hospital. Okay. The data never leaves the hospital. Instead, they will train the model with their own local patient images. Now, after local training, each hospital sends only the model parameters. That's what I have said, that it is a weight. When we are talking about a network, when we are talking about a model, we used to say always the term weights. The weights will be sent back to the server. So in the previous example also, all the 4 hospitals will be sending a weight to the general model, to the server. Now the aggregation means server aggregates all updates using algorithms like federated average to create an improved global model. So what they will be doing, they will be creating a federated. So as we know how to take an average, same concept only, with the help of the weights, the federated average will be taken to create an improved global model. So these steps will be repeated until the global model converges and the accuracy is met. So we knows that when the accuracy has reached to the expected level, then the iteration we can stop the epochs, the iterations. So the final model is then shared with the hospitals for local use. So you may ask me, what is the application? This automated diagnosis support only. So if this is an image, if the image is likewise, maybe if you are taking a brain tumor image, and suppose if you are having slight changes over here or the edge is detected likewise, then you can understand, we can confirm that this is this one brain tumor with this stage or else not brain tumor likewise. Some model is generated and the model is being generated made as a global model, and it has been given to the local hospital which is participated in the federated learning. So this will be very useful for the caretakers, or I can say whether very useful for the medical practitioners to understand whether that image is whether the patient is or the person is having a tumor or not. So this is the step-by-step procedure. Now, so we'll see this somewhat in depth each and every step, and then we'll move on to the this one. What is it? Program. 1 minute. Okay. Now we can see this is multiple hospitals train a shared global model by training locally on their private images. The same concept which I have said has been repeated here, sending only the model updates to the coordinator, and then we are going to aggregate it. So first thing is we are going to take the participants as well as the coordinator. Okay, fine. Now we'll have some hospitals, each with private image data sets. Maybe the images are of different file formats. And there is a coordinator who is nothing but the server. Here I have said in initialization, a central server is there. So this central server is nothing but the coordinator which is specified here, or he will coordinate the rounds as well as aggregate the updates. Now global model initialization, this coordinator will initialize the weights and shares with selected clients. Now client selection will be done and the coordinator select a subset of clients, and this kind can be all clients or a sampled subset also we can take. Now this will be done with the local training on each selected client, receives current global weight, and this network has been trained, local training on its private data set for the set number of local epochs using minimatch SDD. This is all we know, as we know what is SDD and all. Optionally apply regularization. So we'll see this with the program also. So I'll move over here, and this is local privacy and compression is optional actually. Before upload, client may clip or weight updates. May add noise. Why we are adding noise? To improve the security only. Compress or quantize the updates to reduce bandwidth, and then for segregate secure aggregation. So then finally upload model updates. Then the secure aggregation will be done and server aggregation will be done. Based upon that only the global model will be generated. The steps will be repeated until 1 minute. Okay, and then finally evaluation and the deployment. Evaluate a global model, fine tune or personalized model at each hospital, deploying it. So this is the diagram. Hospital A is having some MRI image, local data stays here. We'll be doing only the local training, and hospital B is having some other and computing the weight, as well as it is having the X-ray image, computing the weight. So upload model updates, encrypted or compressed. Okay. So to the, and all these will be sent to the hospitals. The hospitals will be sending it to the server. Okay. So all the weights are being aggregated and finding the Fed average, that is federated average has been created, I mean generated or calculated. And after that, a new global model is generated, and then it is broadcast to selected hospitals. Madam, can you make Mr. Abhishek DG as co-host? Hello, ma'am. Ma'am, can you make Abhishek DG as
Yes.
co-host?
Yes, ma'am. Yes, ma'am. Just a
Yes,
minute.
ma'am. Yes, ma'am. So this is the way how the federated average calculation is done. So calculating all the weights from the clients, this federated average is calculated, and then a global generated model is generated, and it has been shared to the hospitals which has been connected. So this will be done. 1 minute. And the future direction of this federated learning is actually, it allows institutions to collaborate on AA model, okay, AA training, without sharing raw data, while quantum computing enhances this process by faster computation. As we all know that why we are using federated learning, to secure the medical image, but still with the quantum computing, this privacy as well as the security is further improved than the federated learning. So the future direction of federated learning is also actually an integrated form of quantum federated learning. And this is what we know, what is federated learning. And quantum federated learning, where we will have this quantum federated learning means the hospitals will try to send the weight to the central server. In that transit period, we will use QKD, I mean quantum key distribution techniques, to secure the data which has been transmitted from the hospital to the server and vice versa. I mean from the server to the hospitals. So this is what. So now Mr. Abhishek will share one code along with the example. Mr. Abhishek, could you please share?
Yes, ma'am. Ma'am, am I audible?
Yes, little bit.
Hello, ma'am. Hello, ma'am. Am I audible?
Yes, yes, audible, audible.
Yes.
1 minute, ma'am. Let me share my screen. Okay. About this project, we have just imported some packages and tools that are necessary for the project to be run. We have imported the neural network, which the PyTorch is helpful for the tasks. Here, torch vision would be helpful in the case of analyzing the images and processing them so that we can understand about the images more clearly and precise. And we have built a neural network which is responsible for the model to understand about the disease which have been passed over time. Whenever it find the disease, the model would be updated by this neural network only. So this part of code does the majority task in the neural network part. Here we can also add that the dropout layer, which the model generalize well than memorizing, so that the model would be more reliable. And about the client part, here we have the trained model by the part would be saved as a PT file. So the model that we can't see, it would be in the format of encoded. It would be an encoded format. On the client part of view, here we can see package named as just a minute. Here we can see a package named as the OPAC, which is a package developed by OPACS, which is a package developed by Meta, which is actually the important package which is responsible for encoding the private data. This package which is developed by the Meta hide the more private data from the client point of view. So the server will be receiving only the important data that are only hidden by the client. So whenever the client hides and send the data by the OPAC, the server side only gets the data which are being hidden, which are the hidden data sent by the client. So whenever the client sends the data, the server only receives the most privacy data. So the server handles everything that is sent by the client. And here we have just 1 minute. Here we have a neural network which optimizes the code. Whenever the whenever the model is sent to the OPACS, the optimizer optimizes the code, and this optimizer actually optimizes this neural network. Whenever the neural network is updated, the optimizer would be notified, and the optimizer would be taking the code and hiding the private data from the client part itself and send it to the server side. So the server only receives the most private data. Consider the model that is trained by Meta, that trained on a large data set which uses the GPUs. Here we have CUDA, which actually figures out the GPU or CPU within it and shift to the CUDA environment, which uses the graphics card and trains the model. The OPAC actually trains far more faster, so the model would be trained in a way that the private data won't be sent to the server side. Now, on the server part of view, we would be getting the data from the client that are protected from the private data, and the server does the remaining part of task, which takes the data, PT data that are shared by the client, and combines it and pass it to the pass it as a neural network to the model trained in the server side. So we will be getting a model that is more reliable and that explains what type of disease the user has. So this part evaluates that. The server gets the data which are sent by the client. It takes it and aggregates it and evaluate the model. If the model is above 70% or 80%, or even for medical related tasks, we would be taking above 90%. So if it's above 90%, it's a more reliable data. And as of now, the important parts are being handled by the OPACS. And if we implement a quantum circuit in it on your future divisions and all. If we implement a quantum circuit, we have to implement it in this opaqueness part. A quantum circuit, if we implement a quantum circuit, the opaqueness would be protecting more reliable data. So whenever a data sent by the client, if it is most to be protected, the quantum computing would be analyzing it and understand the patterns and won't share the most complex data to the server side. So the data would be more of privacy. And I have a short image that explains how the process is done. Consider this, we have several hospitals. The hospitals would be containing the data that are trained on themselves. Consider MRI scans report that include profile photos, the phone number, the contact information and all. In a particular hospital itself, they would be containing several data. So if they send it to the server side, their privacy would be on a question mark. So they cannot send the entire data to the server side. Instead of that, they would be keeping the most protected data themselves. So they would forward the important data only to the server. So it may lead to some prediction failures. So instead of handling those prediction failures, we have to take the data from the client and protect it with opaque and send it to the server. So the server combines the data that are handled from several hospitals and protect that the protected data. From the protected data, it would be taking some predictions and provide us the data. And we use the hello, am I audible?
Yes, Mayas.
Okay. Let me explain the neural network. Here we will be using the sequential neural network, where the neural network would be sequenced. So whenever a data is passed to the sequential neural network, it would be in a format of tensors. These tensors perform a mathematical calculation. Here the relational operator would be passing it to the next neural network. And if we can add a dropout layer here, so that the model would be learning from its mistake. So consider this model like a child. If the model understand everything clearly, or if the model is 99% accurate, we can say that it's a faulty model, because it may be memorizing everything instead of generalizing. So we can also add a neural network like dropout. So whenever a model lands, it forgets some part of the data. So the previous data, it would be it learn from the previous data and make prediction based on the previous data. So the prediction would be more accurate, even though some part of the data is lost. The prediction would be accurate, so we get a reliable prediction. The data would be forwarded to the many neural networks. Consider it like actually this is a sample neural network. Here we have many layers. These layers are responsible for calculations. The same part of code, we would be implementing it here. The model lands from this part of code. Here we would be sending the epsilon to 5.0, target delta to 1 e to the power minus 5. And we would be implementing an optimizer to here. So whenever a model lands, the model lands from its mistakes, so that we implemented a dropout layer here. And we would be passing down the data set here. So the model would get a data set, and we would be splitting the data set on this part. It's like on this part, we would be implementing an optimizer which optimizes the code and provide a reliable data. And I have already explained about the Opacus, which is a model, which is a library developed by Meta, which helps to protect the data from the protect the most important data. And that's all about client part. About server part, here we'll be getting the data from the client and aggregating the data. The server side would be taking data from multiple clients, as I shown from the image. The client, I have created just a single client, so it will be explaining about it detail. We would be having more client like this. So for each hospital, we would be having multiple clients. So for each clients, we would be getting more PT files, which is a binary file that human can't see, which is then modified by the Opacus, which hides the data and send it to the server. So the server aggregates the process and pass it down as a model to the user. Here we have implemented the system part of view. We would be passing the data from CPU to GPU, so the tasks are being run far more faster. So if we have a heavy CPU, heavy GPU on our servers, then we can run this task far more better. If we have a CPU, there is a problem. The CPU won't be having more tensors, so the mathematical problem won't be consider it as a matrix multiplication. This neural network concept as a mathematical calculation. Actually, GPU come into action when these matrix multiplication are done. So the CPU has less cores, so the calculations are done very minute, or the calculations are being performed very slow. So when we implement a GPU, the matrix multiplication would be done far more faster. So the GPU consists of multiple cores, so they can pass down the values to nearby tensors. So the matrix multiplication would be faster. So we are switching to the CPU to GPU. If you have more doubt about the GPUs, just browse through it, because nowadays in the AI era, we have to know more about GPU, so we can perform many tasks easily. So and about our future point of view, we have some ideas. Just hold on for a few minutes. I shall share a photo. Actually, it's a neural network. I have to fetch it. It would be taking so long. Actually, it's a neural network developed by quantum computing that we have been working on quantum computing too. So we'll be achieving it far more quicker. This we can improve this opaque. Uh, we can improve the opaque by quantum computing. If we pass down the qubit to each output, if we consider if we get some notes like consider we have data like brain tumor, uh, contact info, name, and phone number. We have to pass each qubit to each rows. Consider we have a brain tumor level as 10 and contact info as some random digit xxx and name as Gokul or something and phone number as 898. If we pass correctly qubit to each columns, so whenever a qubit operation is performed, we will be generating quantum computing gates. These gates would be accurately performing an operation that help to find out the pattern between the data. So if the data is more private one, the quantum computing understands it and pass and train the model far more better. And that's all about the code. Thank you.
Thank you, Mr. Abhishek. Madam, that's all. We have ended up the session. Any queries, ma'am?
I have one doubt, ma'am.
Yes, ma'am. Hello.
Hello.
Yes, ma'am.
Sir, I have one doubt, sir. Sir, in federated learning, while, for example, in hospital A, we are, if suppose we are using the brain tumor data, in hospital B, we are using X-ray data, that is a CT scan. Next, in hospital B, we are using X-ray means, and how this update model bias and weight will be used for that is the model updates will be used to for hospital B to train its own models.
Can you come again?
Because in federated learning, in horizontal federated learning as well as in vertical federated learning, either we the in two clients, either the samples must be same or else the labels must be same. Then only we can update the model for different clients. Sir.
Yeah, about that. We can on Python code itself we can set up the data must be in a format of this. So the every client would be having the data in a row column format or column row format. So it won't be an
Because
issue if we keep the application itself on that manner.
Sir, here we are using X-ray data, and another hospital we are using CT scan. The features will be different, no, sir. Then how we can integrate, how we can
Uh,
aggregate in
no,
servers? Because the
no,
model weights and biases for the each neural network will be different. Then how we can aggregate in servers?
yeah. On server point of view, on server point of view, we will be having some sort of code that would be merging these. We would be getting the PT from this client part of view. Now we would be taking the PT and updating to the server. On the server, we would be performing some tasks. We would be with a model, with a predefined model. We would be merging these PT. So we would be getting a better code. Can you understand? Hello.
Sir, how this features will be same, sir?
No, it need not to be same if we have a predefined model. If we have a predefined model and update the existing model, we need not need to have a model that need to be in the same format.
Okay, sir.
Just consider a chatbot which is a predefined model. We'll be fine tuning it so that the model won't be need to be in a format uh, of same rows or same columns. So if we have a pre-existed models, we can update the model each time. So our model would be more precise.
But in the theory level, they are giving we should have, or while training, we should have same features or same common labels for between the clients. They are saying theory level. How it will be implemented in a real basis?
Even if we have a different data set, just consider the hospital one has 1,000 data of different columns, which is a MRI scan, and another hospital has heart patient, uh, which includes some n number of data. On the server, we need to have a model uh, which is actually a predefined model. Just consider Olama, which we use for chatbots. We can integrate or if we need a new model, we can create with multiple amount of data. So if we use a pre-existed model, we can. Ma'am? Hello. We have a pre-existent model. We have to update this model to that pre-existent model so that we would be getting a more accurate result.
Okay, thank you, sir.
Any more doubts?
Participants, if you have any more doubts, you can ask now. Okay.
Good evening, sir.
Yes, ma'am.
No, sir, actually, yeah, using this federated learning, you have collected the data. But as a scholar, how to access this database for research purpose? Because it is having different images like CT scan, MRI, and all those things. But when it comes to practical real-time application, I may be working only on MRI, only on CT scan. So how to get the data, because you are finally aggregating all the images and keeping it as a one set.
Yeah, on the server point of view, we can't retrieve the data because from the client itself, we would be sending the protected data. So we can't get the protected data on the server side. On the client side, we can fetch the data from the database, uh, but not from the model. From the database, we can get it. So
That is what, sir. From the database also, even if you said if it is like from the database, if we are going to collect, it is a combination of all the images.
yes, ma'am. Actually, the data, if you see some data sets now, for a patient, they would be having the data set in Excel. So if we need a particular data from the clients, I'm speaking about the client side, we can't fetch the data from the server side. If we need to retrieve a data from the client side, we have to fetch manually from the database and get it. But once the PT is generated, we can't fetch the data manually. We have to create a neural network, the neural network that we have pre-existed, and fetch the data. Unless until we create a neural network that is similar to the neural network which it was trained, we can't retrieve that data.
Okay, sir. But when it is not able, when we are not able to fetch the data, then what is the use of having all the data only for privacy purpose? You are making all this data aggregate and kept it in the server. Only that is the purpose, sir.
No. For on client point of view, we can retrieve the data before the PT is generated. Even after the PT is generated, we can retrieve the data from the Excel. After the PT is generated, we would be using the PT to the server side only. So we won't be using the PT on client side, or we won't be using, just consider we have to create an AI model that would respond to the disease, but disease by the data we provide. So before updating a particular data to the server, it won't respond about the disease. So the data would be in a encrypted manner. From that encrypted manner, we can't retrieve the data. If it pass to the server only, it would be providing us the data. Unless until it reaches the server, it won't be providing us the disease about the disease from the data. Can you get it?
Okay, sir. To some extent, I would be able to understand, but I think in further classes, I may get this point.
Okay.
Thank you, sir.
Any more doubts?
There is a question in the chat box. Can I get some information about attenuation corruption? Correction.
I didn't get it. If someone
Sir, using free GPU, can we train this federated learning model, sir? Medical images using a free GPU. Can we train this image data set, sir?
ma'am, actually
By
about
federated
GPUs
learning.
now, if we ma'am, actually about GPUs, if we have a high spec GPU, the time would be far more reduced. Consider it like if we have a consider it as a train, ma'am. If we have
What asking
more
means
compact,
using collab, I am having only a small resource now, GP resources, free
okay.
resources.
Okay, I get it, ma'am.
Can we
So if we have a large data set, it would be taking more time, ma'am. About 3 hours.
federated learning, it will take a large time now, sir, because
Yes,
we
ma'am.
are training different clients.
Yes,
That's
ma'am.
why.
Yeah, I'll be coming about that. If we have more data set now, it would be taking about three. If we take 3+ hours, the Google Collaborate cost about some dollars. So better if we have a large data set, we have to use HPC or a laptop with high specification map. So it would be helpful. Um, if if you are try to do some sort of project like this, I would be suggesting a 4060 graphics card laptop. So it would be performing the task more quicker.
Okay, sir.
Any more doubts?
No more doubts, I think, sir.
Thank you.
Thank you, sir, for clarifying all their doubts and queries. On behalf of all the participants, I sincerely thank you, Prela ma'am, for such a wonderful and informative session. Your valuable inputs have enriched our FDP. We thank Abhishek sir too for the excellent demonstration and doubt clarifications. Thank you, ma'am and sir. Now let's start the next session of our FDP. We are delighted to welcome back Mr. Sai Satish, founder and CEO of Indian Servers, who shared valuable insights with us on day one. It's a pleasure to have you with us again, sir, today to continue enriching our learning experience. Over to you, sir, now.
Thank you, madam. Yeah, hi all, namaste. Welcome back. So, hope you remember what we have discussed on the first day. So, do you remember what we have discussed on first day? We have tried YOLO model, right? What we have discussed, can anybody, how many of you completed that YOLO project? Please do respond in chat box. We discussed Google Teachable Machine, image classification, object detection, right? How many of you completed that YOLO project? Please do respond in chat box. Hello. Okay, Manraj sir done. Who else? Who else completed? Right, teachable machine. Okay, perfect. Satya madam already completed. Completed YOLO. What is the full form of YOLO? You only look once is a full form of YOLO. All three members completed the task. What about remaining? YOLO completed. YOLO N. N for nano version. You only look once. Perfect. So today we are going to see some NLP based stuff again related to medical. Okay. Not only medical, we'll discuss other things also. NLP, natural language processing. It will take our natural language as input and gives in our language. For example, if you get stomach ache or headache, okay, what will you do if you get stomach ache or headache? You take some tablet. Okay, otherwise, let's take some other thing. If you have some issue, what will you do? You'll go to doctor and you'll share something to the doctor. You'll say something to the doctor, right? What you are saying some text. You're just saying some text. Then doctor, based upon your input, he will understand something. He will classify the issue. Classify the issue what you got. For example, if you say headache and vomitings, what might be the disease? Please do respond chat box. If you're having headache and vomitings, what might be the issue? Please do respond chat box. Say something. Say some disease. Okay, vomiting plus headache, some infection, stress you are saying. Okay. Now second one, shivering, headache, fever. Shivering, three words I'm using here. Shivering, headache, and fever. Now what might be the disease? Please be active. I'm expecting active participation from all the participants. Cold, only cold. Fever also there. Okay, it might be dengue. Okay, what more? Typhoid, flu. Okay, one more. Let me add one more. Red eyes. Red eyes, fever, headache. What might be the issue? Okay, perfect. Most of you are saying different type of answers, but different type of text inputs, right? For example, Last time we did image classification, just 2-3 days before, we did image classification, right? I think day before yesterday, November 10th, right? So now the issue is with text. Now I'll give some symptoms as an input. Now you have to make a chatbot. The chatbot should understand this, should take the inputs from the user, and it should classify the disease. What's the word I'm using here? Classify. Further, do we have any data sets? Yes, some data sets are there. Just go to the website called huggingface.co. One of the most important websites for AI, guys. Here you can see data sets. Click on data sets. Here you can see, if you type medical based data sets are available. MED. Medical based data sets. Almost 5,000 plus data sets are available. Medical common question answers is available. Some sort of articles, medical question answers. N number of data sets are available. You can fine tune your custom neural network with these data sets. Okay. Now, I don't want these things. I want like symptoms and diseases. Let us check whether we have any. Yes. Clinic symptoms and diseases, version 1. Let us open this. See here. Here, if someone says like this, if your child has something, see here. See the text. If someone types like this with these words, the symptom may be, sorry, the disease may be this one. For example, if someone types like this, it will predict this might be the disease. Like this, data sets plays very, very important role. Okay. Dry eyes. If someone says this, no need to say as it is. No need to say as it is. If some of the words like this, we'll train the model. This will be the input. This will be the classification. Okay. Like this, how many records are there? Almost 1,000 records are there. 1,000 records. See here. Okay. Coming back. Again, we'll go and search for symptoms. See here, diseases. Almost 5 lakh records are there here. Symptoms and disease. Yes, see here. Panic disorder, anxiety, nervousness. So this data set plays very, very, very important role. With this data set, you can train the model. You can fine tune the model. What's the word I'm using here? Fine tuning the model. There are plenty of pre-trained models are there. Example, Llama. Last time we have discussed Q1. Did we discuss Q1 last time? Please do respond chat box. Did I show you Q1 last? Sorry for this. Almost every day I'm taking some sessions. So I don't remember what we have discussed in the previous session. So did we discuss about Q1 last week? I mean, in the previous session? Q1. Say yes or no. No. Okay, fine. Now we'll discuss the Q1. You can fine tune Q1 also. Please log in with your laptops. Just switch on your laptops. Let's just do it parallelly with me. Okay. Hardly 1.5 hour session. Please pay attention. In this 1.5 hour, we'll play with NLP, natural language processing, and few Hugging Face models also we are going to see today. Yes. So data set, when it comes to the database data sets, this is text-based data set. So how to play with this? So how we are going to make a simple project now, a simple program. Open Hugging Face, all of you. How many of you joined from your laptops? Please go to reactions, raise your hand. Go to reactions, raise your hand. How many of you joined from your laptops? 1, 2, 3. Only 3 members. 4, 5, 6. Okay. Others just join from your laptops. Switch on your laptops. I'll show you 2, 3 times. You can do it parallelly with me. Okay. Dataset are available in the same Hugging Face. If you click on models, these are different type of things what AI can do. These are different type of things. For example, if you come to natural language processing, NLP, these are some of the important tasks. When it comes to computer vision, these are some of the important tasks. In previous session, I think we have discussed object detection using YOLO and image classification. These two things we have discussed. Now we'll discuss text classification. Select the text classification. Select text classification. What is text classification? One second. Yeah, text classification. What is this text classification? If you pass the input like the symptoms, it should predict. It should predict the disease. Okay. So I'm taking one of the models. Some lakhs of models are there. 1 lakh models are there. Okay. 1 lakh models are there. 1 lakh models. So I'll select one of these models. Hold on. Yes. I will select one of these. Distilbert is most popular model. They will predict, it's called a sentiment analysis. Also, we can do a few more things. Hold on, let me check the best one. Well, just switch on your laptops, open huggingface.co. I'm selecting some random. How many of you opened this huggingface.co? After opening this huggingface.co, click on models, then click on tasks. Okay. Now select text classification. Okay. Text classification and sort based upon the total number of downloads. Most downloads. Sort based upon the most downloads. Now let me check couple of. Yeah. This is Twitter based model. Open this Twitter based one. Yeah. Sort based upon the total number of downloads. Okay. Sort based upon the most downloads. Just open this Twitter XLM Robota. Open that. Done opening. Here there are 3 lines of code. Just copy this code. Come back to Google Colab. Open Google Colab. What is this? This is sentiment analysis. If someone shares a text to you based upon the input, for example, Amazon reviews are there. People will keep on writing lines and lines of reviews on it. So if you want to check how whether it is positive review or negative review, these type of models will help you. Even in Twitter, people will keep on sharing some posts, right? If you want to check whether it is a positive or neutral or negative, then these models will help you. I'm just pasting here the code. So I'm running this. Let us check the percentage, the probability, whether it is positive or negative or neutral. This sentiment analysis, few models are there. It will give you, for example, if you train with proper labels, not only positive and negative, neutral, it can also give you direct label, like especially for disease. If you give that particular text, input text, it will directly predict the disease. I'll check that one also. Wait for a few more minutes. It's loading. Yeah, within few seconds, we'll get the output. Yes, it's loading. Wait for a few seconds. We'll get the output. Satya, madam, you have to do one thing. Like you have to install transformers.
Okay.
Yeah, Dolly, I'll just share the information. Hold on for a few seconds. First, go to Hugging Face. Dolly, just go to Hugging Face, then click on Models. After Models, just come to Tasks. After Tasks, select Text Classification. Text Classification. After selecting Text Classification, just select Sort based upon the most downloads. Now you can see the top. You can select Twitter Roberta. Yes, we got the output. So the sentence is the text here is positive. Okay, let me change the text. I love coding. Let me check the result for this. Positive, negative, or neutral. Yeah, it is saying positive. Again, 89% it is sure that particular line is positive. Uh, I hate eating more food. Okay, let us check whether it is negative or neutral or positive. Yeah, it is saying negative, and 85% is it is sure it is negative. Okay, I love eating less food. Both the things are same, but the way how we are expressing it looks whether positive or neutral. Okay, now it is positive. It is saying positive. How many have done this task? Please do respond chat box. I'm going to repeat this for the second time. Just pay attention. What is this text classification? First thing is sentiment analysis. Okay, text classification also we are going to see. This is also classification: positive, negative, neutral, classifying. On first day, what we have seen, image classification we have seen. Now we are seeing text classification. Okay, we'll take the inputs in text format. Based upon that, we'll decide which class it belongs to, whether it's positive, neutral, or negative. Let me check. I forgot that name, that special library. Hold on for a few seconds. I'll show you that. That's one of the fantastic one. Just give me a few seconds. I'll check. Surely it will be the top. Yeah, hold on. Let me check one of the things. Not this. Okay, this one is for emotion detection, whether joy, happy, sad. This is not just positive, negative, and neutral. Emotion text classifier is there. You can give it a try that one also later. But I'm checking for more. Hold on for a few seconds. No, I think I lost the name of the project. Yeah. Okay. Anyways, this is a text classification. Okay. Here you can see something related to medical also. See here, oncology, pathology, DNA detection. I don't know how the accuracy of these models, but anyways, few things are there. For an year, it is there, name entity recognition. For an year, Few models are there. If you wish to try, you can give a try. But I don't know the accuracy of these models. Already some lakhs of downloads already done. Some lakhs of models for this open medical related stuff, especially NER, name entity recognition. For example, if you take a textbook, engineering words we can understand. Okay, engineering words we can understand, but it's not easy to understand the medical terms for me. I don't know about others, but for me, it's not easy to understand the medical terms. Since I'm from computer science background, I can understand technical terms, but not medical terms, right? For that, we use this NER, name entity recognition. We can use this for oncology detection. Maybe it's a dictionary, genome detection. Okay, anyways, we are not going to touch this token classification. Okay, next one, what we're going to see is text generation. Text generation. All of you open text generation? All of you open text generation? Okay. Here, this is now we are going to build a mini chat GPT. Okay. We are going to build a mini chat GPT. But chat GPT is closed source. If you want to play with open source models, some open source models are Qwen. This is from China. Alibaba, one of the most powerful LLMs. Most powerful LLM, Qwen. Llama. This is from Meta company. DeepSeek. This is also from China. One of the guys from China, they started this DeepSeek. Like this, plenty of LLMs are there. If you want to see some of the open source LLMs, search with the word called Hugging Face Leaderboard. Hugging Face Leaderboard. Scroll down. Here you can see some of the open source LLM, Open LLM Leaderboard. Based upon, based upon your requirement, you have to select respective LLM. For example, if you want to make LLM related to mathematics, so sort based upon the mathematics. This is a benchmark. Okay. Ace Math from NVIDIA, it is performing better in mathematics. Number one, almost number one, with 71% accuracy for mathematics related. But when it comes to general public questions, see here, these are general public question answers. Only less than 3% are right. So when you're building a model, when you're building a chatbot related to mathematics, you should not use this. Sorry, for mathematics, you should use it. For general public question answers, you should not use it. Check which is better for general public question answers. This is looking top in open source. Based upon the performance, you have to select. Okay. Now coming back to our Q1. How many of you opened this text generation models? Do respond chat box. We are going to build our own chat GPT now. Chat GPT in the sense our own LLM. We are going to use some open source LLM. How many of you open text generation? Do respond chat box. I'm expecting at least 10 members to respond. 10 members. Say something in the chat box. 1, 2, 3, 4, 5, 6. 3 more. 3 more. Be quick. 4. Okay. 2 more. 1 more. 1 more. I want at least 10 active participants to do parallelly with me. 1 more. 1 more. Okay, done. See here, after selecting text generation, you have to select, see, some lakhs of models are there, almost 3 lakh models are there. There are 3 methods. You can create your own ChatGPT kind of applications. The first method is using APIs. Using API. On first day, we have discussed how to use Gemini API, right? Did we cover that concept, how to use Gemini API? I think we have covered. Did we discuss that one, Gemini API? Oh, not discussed. Okay. Okay, I'll show you that Gemini API also. Just pay attention. Gemini API also I'll show you. Gemini API. I want at least 25 active participants. Okay. Gemini API also I'll show you. First method is to use APIs. Second method is to use open LLMs. Okay. Third method is to create your own LLM. Own LLM. Even this is not easy task. Creating our own LLM is not easy task. Fine-tuning huge tokens and fine-tuning huge corpus is not easy task. These two are easy. Using API and using OpenLLM, these two are easy. First, I'll show you how to use OpenLLM. Example Q1. Open this text generation. Here, you can type Q1, QWEN. Then it's going to show us the different models of Q1. If you notice here, just see the screen once, 7B. 7B means 7 billion parameters. 0.6B, 0.6 billion parameters. 0.5 billion parameters. 4B, 4 billion parameters. 32 billion parameters. If you want to run 4 billion parameters, you must have 6 GB GPU. I'm not saying RAM. I'm saying GPU. You must have 6 GB GPU. To run 70 billion parameters or 80 billion parameters. See, if you go to Llama, if you click on download models, they'll show you different, see, 109 billion parameters, 400 billion parameters. To run this 400 billion parameters, you must have some terabytes of GPUs. Parallelly, they should run terabytes of GPUs. Okay, not just RAM. You need GPUs, high-end GPUs. You have to invest some crores of rupees to get that. Even to get 256 GB GPU, you have to invest around 15 lakhs. It's not easy task. You have to invest in the total server, you have to invest around 15 lakhs. So what we'll do is, we'll go ahead with 0.6 billion parameters. Select this 0.6 billion parameter Q1, open this. 0.6 billion parameter, open this. Scroll down. Here you can see the code, how to use that 0.6 billion parameterized LLM. Copy this code, open Q1 0.6 billion parameter, copy this code, done copying. Yeah. After copying the code, what you have to do is come back to Google Colab, just select runtime. You must have GPU. Without GPU, it's not, you cannot run this. Just go to runtime in Google Colab, change runtime. Select T4 GPU. Choose OK, save it. Yes. Just connect to GPU, take a new code cell, paste the content here. And here is a question. Here is a prompt. Give me a short introduction to large language models. I'm going to run this. It takes 2 or 3 minutes to load all the required libraries. Then it's going to show us the output. See, repeating. Come to text generation. Select Q1, 0.6 billion parameterized. 0.6 billion only you have to choose. Otherwise, your GPU will not be sufficient. So just open that, scroll down. You can see the code. Copy the code. Open Google Colab. Take a new notebook. Otherwise, just continue with the previous one and change the runtime to GPU. Change the runtime to GPU. Yes, done. We got the output here. You can see a large language model introduction from Q1 0.6. Let me know if you have any questions. Let me know how many have I done. Just post the response in our chat box and change the question. Ask to tell a joke. Just in the prompt, ask to tell a joke. Tell me a joke on physics. Tell me a joke on chemistry. Um, tell me a joke on physics. And post the response in our chat box. I'm expecting at least 10 members to complete this task. It's taking time. Yeah, you need GPU. GPU is mandatory. Just go to runtime. Just go to runtime, change the runtime. It hardly takes 2 or 3 minutes. You'll get the output. Yes, we got the physics. Yeah, Satya, please post the output in our group. We got the output here. Only one done. Only one. Others, if you have any issues, just unmute yourself and can ask me. Okay, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. Now, we just played with one LLM. You can fine tune these LLMs with these data sets. These are pre-trained models. These text generation models are pre-trained models. Just download the data set, fine tune it. Okay, fine tuning is important. Otherwise, it won't give you a better results for your customized product, customized applications. Okay, coming back to the next one. Text classification we have seen, text generation we have seen, summarization also you can try. Summarization, select summarization, select summarization. Yeah, come back to Hugging Face, select summarization. Now scroll up, select Facebook, sort based upon the total downloads. Select Facebook, most downloads. Where is the Facebook? Facebook, where? Summarization, natural language processing. Somewhere you can see the Facebook.
Sir, in search, you just modify the training model as well.
Oh, right. I still mentioned Q1, right? Yes, see here, Facebook Bart is there. Facebook Bart. Just open this Facebook Bart. Facebook Bart. Scroll down. Here you can see the code. Just copy the code. For remaining things, only to play with images, you need GPU. For few LLMs also, you need GPU. For basic things like these things, for summarization, you don't need of high-end GPUs. If you have GPU, it will be quicker. Even without GPU also you can run, but it will be slow. Okay, just copy the code. I am removing the last line. Actually, last line is the output. I am removing the last line. Okay, last line has been removed. Now I'm going to run this code. Now it takes hardly 1 minute. Then you can see, and then you can see the output. Within 30 seconds, we'll get the output. Yes, we got the output here. Just give it a try. Create Facebook summarization. Use Facebook, large Bart, run the code. where we can use these things. For example, if some people will keep on writing more number of pages to you, we will not have that much time to read all the content. Then if we use these summarization tools, just in 3 points or 4 points, it will give you all the details. Yes. How many have done this task? Just respond chat box. Those who are done, just respond like summarization done or summary. Okay, 1, 2, 3, 4, 5, 6, 7, 3 more, 8, 2 more. Okay. Now again come back to Hugging Face. Select models. Select tasks. Last time we have discussed one concept called YOLO. You only look once. YOLO can be used for pose detection, segmentation, object detection, classification. Now here YOLO is one. Like YOLO, there are some thousands of models which can perform similar activity. Click on object detection, all of you. Come back to Hugging Face. Select object detection. Select object detection. And sort based upon the more number of downloads. Almost 3,000 models are there. Sort based upon the total number of downloads. Yes. Here you can see one model called ResNet, Facebook ResNet model. Open that. Scroll down. Copy the code. How many of you open Facebook ResNet model? Do respond chat box. Just open Facebook ResNet model. In previous session, we have discussed YOLO. Now we are going to play with Facebook ResNet. Yes, see here, repeating. Just open Hugging Face. Select models, then click on tasks, then select object detection and sort based upon the total number of downloads. There you can see Facebook ResNet. Open this. Scroll down. Copy the code. Come back to your Google Colab. Take a new code cell. Paste the code here. Paste the code. What is the purpose of this? Object detection. I'm opening the image. In the image, you can see two cats are there. Two remote controls are there. One sofa is there or couch. Okay. Total 5 items are there. 5 objects. Sofa, 2 cats, 2 remote controls. Now I'm going to run this cell. This ResNet is going to return the list of objects in a list. Okay, it is going to return the list of objects in a list. It contains the object name, XY coordinates, X, Y coordinates, height and width of that object with confidence level. Let's wait for a few seconds. It's going to show us the data. Yes, if you notice, you can notice 5 objects with this confidence level, 2 cats, X, Y, height, width of the object. Object name is remote with this much confidence. This is a list you will get. YOLO also gives a similar result. After that, you have to process that. YOLO, if you observed on first day, we have seen broken bone, brain tumor, n number of medical images we have worked on, tooth cavity. Same way, you can play with this object detection, but you have to fine tune it. If you don't fine tune, your model will not give you proper result. It cannot understand. You have to fine tune it. Okay. Now moving to the next concept, Gemini API. Last 15 minutes. Pay attention. After this, we'll go for Q&A. What type of projects you want to develop, we'll discuss those concepts. Last concept, all of you open this thing called aistudio.google.com. Are you sure we have not discussed this AI Studio last time? Please do respond chat box. Not discussed. Okay, fine. We'll discuss now. Just open aistudio.google.com. aistudio.google.com. Now click on Get API Key and Create API Key. Click on Get API Key. Then click on Create API Key. Set a name here. Set a name here. Create a project, create the key. 1 minute time, just create the key. Then you can copy the key like this and paste in our chat box. 1 minute time, just open aistudio.google.com, aistudio.google.com. Then click on Get API Key. Then click on Create API Key. Create an API key. Copy that, paste in our chat box. 1 minute time, be quick.
Sir, after naming the API key, whether we
Yeah,
have to change anything, sir, it's not open.
I didn't get your question, madam.
Sir,
After creating a,
after
name
clicking
it.
create the new key, we have to choose it for a project, sir.
Yeah, create
Choose
any
an input.
project. Yes, create any project.
Okay. Uh,
I'm waiting for API keys, only one posted. Okay, others also be quick, just create an API key. After creating an API key, those who could not able to create API key, just use others. But make sure others just delete API key after completion of this program, because API keys can be misused, and if someone misuse it, you'll be charged. You have to pay. Okay, per day they'll give you 1 lakh tokens for free of cost. One token means one word. I'm opening this key, copying it, paste in Notepad. Just copy this and paste in Notepad. Paste in Notepad. Then we'll reuse it. Now come back to aistudio.google.com. Sir, those who got disconnected, don't worry. Just follow from now. Some of you already posted API keys. Just copy one of the API keys, use it. Yeah, come back to aistudio.google.com. Here you can see documentation. Just click on the documentation. Just click on the documentation. Here you can notice a code. Copy this code. Copy this code. Open your Google Colab. Open your Google Colab. Copy the code from the documentation. Copy this code. Come back to your Google Colab. Take a new code cell. Take a new code cell like this. Take a new code cell. After taking new code, just paste in the cell. Don't run. There is some modification. I'll tell you. How many of you done pasting the code? Just respond chat box. Just mention done. Once you are done pasting the code, just mention done. We'll move to the next step. Manraj sir, just copy someone's API key. Just copy someone's API key. Go to documentation. Go to documentation, which is available in AI Studio. Copy this code. Paste in Google Colab. Don't run. I'll tell you when to run. Small modification is there here. After pasting in Google Colab, in the client, type like this: API underscore key equal to, in single quotes or in double quotes, API underscore key equal to, in single quotes or in double quotes, paste the API key which you have created. Okay, paste the API key. In client, API underscore key equal to, just paste the key. Now you can ask any question here. Tell me a joke. Now, if I run this cell, you can notice the response from Gemini. Earlier, what we have used? Earlier, we have used Q1. API key, what happened to this API key? Model is overloaded. Anyways, let me run one more time. I'm running it one more time. Yes, we got the response. Yeah, right. Satya madam, just rerun it. Run it again one more time. Just post the response in our chat box. Error, rerun it. Shalini madam, just tell me, let me know what is the error. What is the error? Post the error in our group, in the chat box, so we can discuss.
Sir, error is regarding, one second, sir. Let me just, secret not found error it seems.
That means you have not given API key properly.
Okay, I'll just check once again, sir.
Yeah, API underscore key equal to, in single quotes or in double quotes or in triple quotes, you have to pass the API key.
Sure, sir, sure, sir.
Sir, these are all already trained models. How we can find
It's a GP. Yeah, pre-run Gemini. This is a direct Gemini. This API, we are directly using Gemini.
Before I use it, sir,
Q1.
Project.
Yeah, Q1.
Sir. How we can fine tune, sir?
You have to, yes, fine tuning. There is a different strategy is there. Long back, I tried this GPU. Do one thing. If you wish to try, if you wish to try with Chat GPT, my GPTs, search with this word, my GPTs dot chatgpt.com. They will introduce you your own GPTs here. Okay, here you can fine tune. You have to upload required documents and you can upload it and you can query. Otherwise, for personal purpose, if you want to play with personal purpose, if you want to release it for public, you can try with my GPTs. Okay, my GPTs, you can upload the documents, Excel sheet and other things. You can play with it. If you want to try with the personal one, Notebook LLM. Notebook LM. This is from Google. This one you can try for personal purpose only. Okay. For public, you can use my GPTs. My GPTs. For Q1, again search for fine-tuning llama. They'll give you code how to fine-tune. You have to use it. Again, you need high-end GPUs to fine-tune these LLMs. You have to pass a data set, question, answer, question, answer, question, answer data set like that, and you have to fine-tune it. Search with this word and we'll get it. Okay.
Thank you, sir.
Yes. Most of you got it, right? Okay, done. Now, last concept for today's session, images. Images. How many of you how many of you do paper evaluation? Do respond chat box? Exam paper evaluation. How many of you go and verify, give marks, award marks for the students? Okay, most of you. How much do you get per paper? Per paper, how much do you charge? 20 rupees or 23 rupees or 19? How much do you charge per paper? Okay, some of you are getting 30 rupees also. 50 rupees. Wow. First time I'm seeing 50 rupees per paper. Okay. Oh, 60 as well as. Okay, Aisha. Let's do one thing. From now onwards, we are going to use AI to evaluate. Okay. If you wish to try, just do it simultaneously, parallelly. First, see it as a magic show. First, see it as a magic show. I'll give you time. You can repeat it. Here, now don't do it now. Just see it as a magic show. I'll show you. After that, after completion of my task, you can give it a try. In Gemini, you can see one option called image understanding. Image understanding. Open this. Image understanding. I'm selecting the third cell. This is the first cell. This is second cell. This is third cell. Copying this. Copied. Coming back to Google Colab. Taking a new code cell. Pasting it here. Okay. Two things I have to change. Sorry, three things I have to change. One is API. Second one is path of the answer sheet. Path of the answer sheet. Third one is prompting. These are the three things I have to change. Within 2 minutes, we are going to make an AI evaluator. So what I have to mention here in client? What I have to type? You already know what we have to type.
API key.
What we have to enter here?
API key.
Yes, API key we have to enter. So it is already in the previous cell. I'm just copy pasting it. Perfect. Second, I have to pass the answer sheet here. First, let me download any handwritten notes. Okay, I'm just selecting some random, saving this image. See, it is not clear, right? Some backside pages are also visible. Backside text is also visible. I'm going to take screenshot of this. I'm going to take screenshot of this. I'm going to save it as JPEG. Okay. I took the screenshot. This is not doctor's handwriting, so no issues with this. I'm saving in my downloads. Just JPG. I just saved this. I'm going to upload it to my Google Colab. I'm going to upload to Google Colab. See here, file browser. From here, we can upload. Uploading the temporary image. Done. Now, right click and copy path. Three things we have to change. The first one is API key. I copied. I replaced it. Second one is the image. Okay. Folder also we can pass. PDF also we can pass. Document understanding is there. No problem. We can pass the document also. Question paper separately we can pass. And students' answer sheets will be in one folder. We can pass in that way also. Yes. See here. I'm changing the prompt here. Prompt is very, very important. Prompt is very, very important. See here what we are going to do. Act like evaluator. Give marks up to 20 based on correctness of the answer. Based on correctness of the answer. And give explanation. This is the prompt I'm giving. Act like evaluator. Now I'm running the cell. Let us see the response from Gemini. Model is overloaded. No problem. This is not your issue. Let's try one more time. Still the same issue. We'll try one more time. Until we get, we'll try. Yes, we got the response. And the evaluation is 20 out of 20. And perfect. We got the result also here. So it can evaluate for $1, it can evaluate 6,000 papers in a minute. So for 50 rupees, you're evaluating one paper. For 50 rupees, for 80 rupees, it will evaluate almost most of the class papers, all the classroom papers, with good accuracy, with proper response. So even if we still think AI cannot replace our jobs, welcome to AI world. It can replace even singers' job also. Yes. How many of you like this image understanding? Do respond in the chat box. But accuracy, yeah, accuracy, it will perfectly check the accuracy of the answer. For example, if you give wrong answer, surely you'll get wrong result. Yep. Shall we try now? Now do it simultaneously, parallel with me. Students cannot write accurately, then they don't get marks. They have to fail. If students are not accurate, they have to fail. That is what ChatGPT will do. That is what Gemini will do. No mercy. If they are right, if they're accurate, they will get marks. If they're inaccurate, they don't get marks. That is what the purpose of exam also, right? Only problematic papers we can check accuracy. What about handwriting? Except doctor's handwriting, it can answer. It can evaluate. No problem. Doctor's handwriting is not that much easy. Okay, let's do it parallelly with just do it parallelly with me. First thing, Students' handwriting are worse. Let them learn how to write that first then. Generally, our program can understand. This Gemini will understand that also. Yes, see here. Just open aistudio.google.com, get ready with the API code. That one already done in the previous session, so I'll not invest much time on this, how to get API key. Most of you are already ready with API key. We already done last time. Now come back to documentation of Gemini. Gemini documentation. Left side, you can see core capabilities. Core capabilities. Under image, select image understanding. Select image understanding. Now leave the first cell, leave the second cell, copy the third one, copy all the content of the third cell. 30 seconds time, copy this, come back to Google Colab, take a new code cell, paste here. Take a new code cell, paste here. 3 things we have to change. How many have I done pasting? Let me know in the chat box. How many have I done till this step? 1, 2, 2, only 2, 3, 4, few more, 5, 6, few more. Okay, 3 things we have to change. What's the first one? API key we have to mention. API underscore key equal to API underscore key equal to. Just paste it in double quotes. First step. Complete the first step. API. It is already there in the previous cell. Just go to the previous cell, copy paste it. API underscore key equal to, paste it. Now download any handwritten notes from Google. If you have in your mobile or in your laptop, just upload that image. Just upload that image. Okay. 1 minute time. Just upload any handwritten notes. Done. How many of you done uploading an image? Just mention that image. Mention the word image. Just mention the word image so that I'll understand that you have uploaded the image. Just download any random image from Google, handwritten notes from Google. If you have in your system, just upload that. Only one completed the task, one uploaded the image. Others also just upload the image to 3, 4. Okay, right click on the image. Right click on the image. Choose copy path. Choose copy path. Paste it in file. Paste it in file. Replace the content in file. Just paste the path of the image. Right click on that image. Paste the path of the image. Okay. And you have to modify the prompt. What is the prompt you have to give? I'm typing here. See. Act like evaluator, comma, give marks up to 20. You can mention for question 1, this is a maximum mark. Question 2, this is a maximum mark. If they are writing better handwriting, give extra marks. If grammatical mistakes, reduce this. If theme is a mistake, reduce these marks. If spelling mistakes, reduce these marks. You can give detailed prompt. Everything will be there in the prompt only. Okay, give marks up to 20 based on correctness of the answer. Correctness of the answer. And give explanation for marks. That's it. Copy this, paste here, and run the cell. Let me know how many of you got the result. If you are getting any error like server is busy, keep trying. Now server is busy. You can make with QN also. QN also will read images. QN also will read the images. Okay, Hepsi got the result. Perfect. For me also, model is overloaded. Multiple times I have to try. Okay, Aisha also got the result. 3. Usha also got the result. Others also can try. Perfect. Yes. Any other questions? That's all from my side from today. Open for questions. Yes, it will come. Open for questions. Open for questions now. Okay, Manraj. For your answer sheet, you got 7 out of 20. Manraj sir, just do one more thing. Just post the reasons. It will give you explanation. Just post the complete out. Neurological disorder data set, I don't know where it will be. Handwritten notes, I don't think for a specific thing. Anyways, just give a try in Hugging Face data sets. Don't just search for neurological disorders. You can create it if you want data sets. There'll be some limited words will be there. Those things can be easily created. Yes, open for questions. Things related to AI or cybersecurity, we can discuss. I think no questions, madam. Over to you. Thank you all for joining the program. We can connect in LinkedIn. Sai Satish is my name. We can connect in LinkedIn. Thank you. Madam, over to you.
Thank you, sir.
Sir, you told that we can create data sets from this model now, sir. Will that be valid when we use this for
No,
research?
creating data set. No. We have to fine tune with these data sets. For creating data sets, don't use a model. That's not recommended. Data sets must be from a real source. Always should be from real source only. We have to fine tune the real data sets. Real data. But it's not recommended to create. What I told last time was, for example, last time I'm fine tuning one mathematics formulas. For example, these things cannot understand formulas easily. These Gemini LLMs at that time, around 1.5 years back. Today they're able to
Okay, sir.
understand. So last time I trained sigma, some sort of symbols and mathematics theorems I have trained. For that, I have generated from a model to train another model. But generally, you should not generate the images to train the model. For example, you should not create an image with lung cancer to generate, I mean, you should not generate such type of lung cancer images. You have to take lung cancer real images from MRI scan. For formulas, you can take mathematics formulas. But for when you discuss about medical, you should not generate the images. Yeah.
Okay, sir.
Yeah. Okay. Thank you. Thank you all.
Thank you, sir. Thank you, sir, for taking both sessions and for the wealth of knowledge that you have shared with us. It has been a privilege to learn from you. Thank you very much, sir. Participants, kindly fill the feedback form posted in the chat box for day 3. We hope all the participants were benefited by both the sessions. We'll meet again tomorrow at 6 p.m. Have a good night. Thank you.